Curt Jaimungal gives insightful interviews on his YouTube channel, Theories of Everything. He's given me permission to quote from his interview with Tim Maudlin, who he introduces by saying,
Tim Maudlin is a professor at NYU, a visiting professor at Harvard and Carnegie Mellon, as well as an influential philosopher of science specializing in the metaphysical foundations of physics and logic.
Here's my own introduction to Tim Maudlin. Tim is a great philosopher of physics. This is exemplified in his book, Philosophy of Physics, Quantum Theory. He's also a wonderful teacher of quantum mechanics, which he explains using a three-phase process. First, we collect facts about the world. This is done by collecting the results from a broad and hopefully representative selection of quantum experiments. In doing this, a number of technical terms, such as photon, spin, atom, may have to be used. At this stage, we postpone considering what these terms mean. Next, we show that the mathematics of quantum mechanics predicts all these facts. This mathematical machinery is quite considerable. It's overcomplicated for predicting the results of any single experiment, but it's elegant and essential for successfully predicting the combined results of all experiments. The final step is to attempt to explain what A and B tell us about our universe, its character, and what is actually going on within it. This task, called finding an interpretation of quantum mechanics, is incredibly difficult. There's been no agreement about this, even after almost a century. Tim is rightly scathing about the Copenhagen School, headed by Niels Bohr, which gives up on step C. Perfectly rightly, in common with Einstein, Schrödinger, Bell, and Aspect, Tim is a realist about the universe. Einstein was right in saying that the moon continues to exist when hidden by clouds. Tim is the founder and director of the John Bell Institute. He wrote an important paper called What Bell Did. He also has a YouTube video about this. Now let's hear Tim describe his pessimism about the prospects for solving the mind-body problem.
Do you see consciousness as a foundational question?
Consciousness I see as the hardest question there is. I think the mind-body problem is the hardest conundrum.
And that's because
you can't even imagine what a solution could look like. Without putting any other constraints, I just don't know. Essentially, what you're asking for is some physics that when you apply it to a physical body in the structural form of a human brain or a dog's brain or, I don't know, an ant's brain, I'm not sure, right? I don't know. Are ants conscious? I don't know. That somehow you see that, gee, that physical behavior would be accompanied by or create or whatever a subjective state like pain. And I don't understand how that could be. So I think that's the hardest problem there is. And because it's so hard, I don't work on it because I don't even understand what a solution would look like. I mean, I've pointed out one of the first papers I published was a paper called Computation and Consciousness, which is just pointing out that a certain kind of attempt to answer that question can't be right. But I don't know what the right answer is. I don't even know. It's not that I don't think there's a problem there. It's that I think there's a problem there that's so intractable.
Yes.
That I don't want to spend my time banging my head against a brick wall.
I want to give an overview of the next part of the video. But first, here are some preliminary definitions. Metaphysics is the philosophical study of the things that exist. What is their character? What are their properties? How do they interact with one another? Physicalism is the metaphysical position that all things are grounded in physics. So we have physical entities, physical properties, and physical laws. Physicalism means that once all the physical facts are known, then all facts are known. Notoriously, physicalism makes the claim that all mental facts, including the fact of pain, can be reduced to physical facts. Idealism is the metaphysical position that all things are grounded in the mental. So we have mental entities or minds, we have mental properties or percepts and agency, and such like things. Idealism makes the claim, or at least it should make the claim, that once all the mental facts are known, then all facts are known. And of course, this includes all physical facts. Here are my reasons for optimism, which I'll explain in more detail later. Future physics will retain unaltered its general mathematical character. Physicalism has been the dominant metaphysical position for about a century, and for the reasons Tim has given, and for many others, it's unlikely to solve the mind-body problem. Alternatives to physicalism are underexplored. A particular form of idealism, Pan-idealism, has some attractive properties. It's fully realist about the contents of the world, and it engages with and is consistent with contemporary physics. Also, it gives a natural space-like foliation of space-time. I think Tim's pessimism stems from his disbelief that any form of idealism could have these crucial properties. Physics as a human endeavor gives an abstract mathematical picture of the universe. Physicalists claim that consciousness is necessarily dependent in a specific way on complicated physical goings-on in a sufficiently advanced brain. As Tim points out, this raises an immediate objection. How can these goings-on be identical to, or give rise to, or necessitate an experience of pain? Future physics will retain its mathematical character, and so it won't give a solution to the mind-body problem. We can develop this into an argument that physicalism is false. In his interview with Curt, Tim is dismissive of Max Tegmark's position. I'll give details in the description. I agree that Max is wrong, but I think his ideas highlight a fatal problem for physicalism. Max holds that mathematical existence and physical existence are the same concept. The universe is nothing other than an incredibly complex formal mathematical system. There is no intrinsic character to any physical object, and there is no extra fact that distinguishes our instantiated world from its mathematical model. Instantiation is thus an empty concept for Max. His reasons for adopting this position are the extraordinary success of physical theories that describe the world in mathematical terms, the lack of any scientific evidence for intrinsic, non-mathematical properties within the external world. For Max, every mathematical object is a physical world. This is an extraordinarily profligate collection of universes, much more so than the so-called many-worlds interpretation of quantum mechanics. The problem for physicalists in particular is as follows. Physicalists must describe the universe in solely mathematical terms. Although they use evocative words like photon, brightness, and field, they must explain these words in terms of mathematics alone. In particular, it isn't legitimate for physicalists to explain such words in empirical terms. I want to explain what I mean by empirical facts. Some years ago, my father Jack built an automatic telescope. It measured the changing brightness of stars by counting photons and saved the results on a computer. I did the programming. Even after the results were stored on the computer, there were still no empirical facts. No empirical facts existed until a human mind perceived the results. So, it isn't legitimate for physicalists to explain such evocative words in empirical terms, because this is to define physical facts in terms of mind. In contrast, the goal of physicalism is to explain mind in terms of physics, and the same applies to all such evocative terms. Given all the points above, how is a physicalist to distinguish between an instantiated world and a non-instantiated mathematical model? There's a heavy burden upon physicalists to answer this question. Max Tegmark's position is unassailable, but it is the reductio ad absurdum of physicalism. We need to seek alternatives to physicalism. My specific idealist position is as follows. The ontology of Pan-idealism is that, roughly speaking, the same entities exist as in physicalism, except they're far richer in their essence. Slightly better, the catalogue C of entities is the same, where C is a complete list of what things exist, molecules, cats, rocks, etc. But in Pan-idealism, all entities have an intrinsic nature. Each and every member of C is a mind. This means that Pan-idealism is a strong but atypical variant of panpsychism. Panpsychism is the weaker notion that every member of C has mental properties. In contrast to standard panpsychism, Pan-idealism rejects physicalism. Each mind can perceive its environment. It possesses agency. Most cannot think. They have zero cognitive powers. Agency is the only form of causation. Structures within percepts give rise to physics. Physics is entirely secondary, and physical laws are merely mathematical descriptions of what is going on. They do not amount to causes. I want to sketch how physics is derived from percepts in Pan-idealism. Some friends are celebrating. Ultimately, their confidence that they are seated at the same table together is based solely on the similarity and mutual consistency of their percepts. The whole history of science is likewise based, ultimately and solely, on the consistency of human percepts. We must simplify. Two people are experiencing the same scene from different perspectives. We don't have access to their percepts, but we may imagine them roughly as shown. We can easily see that these 2 points correspond to one another. Likewise, these 2 lines. By combining the percepts of many observers, we can pick out 3D mathematical structures within the scene. This hints at a definition of physical space. Physical length is, at least by provisional definition, identical to the optimal synthesis of perceived length, derived by combining the percepts of human minds. This is certainly the way in which humans, in truth, arrive at the concept of length. The optimal synthesis is the mathematical object which best combines the mathematical structures that exist within all percepts. This is entirely a mathematical concept. It doesn't require any omnipotent observer with access to the percepts of all minds. A fatal weakness in this definition as it stands is that it gives an extremely incomplete anthropocentric ontology for the universe. Consider the moon when hidden by clouds. We need to amend the definition slightly. Physical length is identical to the optimal synthesis of perceived length, derived by combining the percepts of all minds in Catalogue C. The minds that exist in Pan-idealism are ubiquitous throughout the universe. The ontology is no longer anthropocentric or incomplete. The particles that make up the moon itself confirm its existence. Although I won't explain this here, we can define physical time in a somewhat analogous manner. Physics in Pan-idealism has several requirements. Because our intention is to describe the correct objective physics of the universe, usually called completed physics, physics in Pan-idealism must be consistent with contemporary physics, which is our best current insight into objective physics. And it must have a clear ontology. Not all interpretations of quantum mechanics have this. It must have a unified description at all scales. Now, it's not immediately clear that our universe actually has this property. But clearly, if Pan-idealism so far described is to have any chance of success, then this is an essential requirement. It must explain goings-on in the universe. Not every interpretation of quantum mechanics does this very clearly. I'm thinking of many worlds. These requirements lead us to adopt an objective collapse interpretation of quantum mechanics. These exist in several variants. I'll use Ghirardi-Rimini-Weber, or GRW for short, here, although other objective collapse interpretations are perfectly fine. To find the true individuals in Pan-idealism, we factorize the wave function of the world as much as possible. Big psi equals alpha 1 times alpha 2 times alpha 3, and so on. No alpha is significantly entangled with any of the others, and no alpha can be further disentangled. Intrinsically, each alpha I is a mind, a true individual, consistent with the holistic nature of consciousness. And because we'll be dealing with dynamics, I'll sometimes call these individuals agents. As an objective collapse occurs, this changes psi, giving rise to a modified factorization. In detail, how does dynamics in Pan-idealism work? Here we have a sketch of the universe at cosmic time, big T. Psi 0 is the initial quantum state of the universe before any collapse events have occurred. That's at the bottom of the screen. The black dots are collapse or localization events, and taken together, the past light cones of these events mark the cosmic past of the universe, which is drawn in brown. The boundary of this region is the cosmic present, which I've labeled now. Blue is the cosmic future, which is still open to various possibilities. Psi t is the current wave function of the universe. It is derived from psi 0 after all the collapse events marked by the black dots have occurred. Individually, and ignoring all others, each agent attempts to land its particles in the future. Each agent must do this consistent with psi t, the wave function of the universe, and also with its own state of entanglement. In the sketch, there are 6 agents which are free particles. On the right, there are 3 agents which are entangled pairs, and on the left, there's an entangled triplet, and also an entangled quartet. But entanglements can be much bigger than this. Which particle landings succeed and which fail? This is done at the level of individual particles and ignoring agents. The rule is, any landing attempt which is in the future light cone of any other will fail. These have been marked with the red crosses on the diagram. All other landing attempts succeed, and these have been marked with the green dots. The reason for this rule is that the successful landings will have disturbed the wave function, and therefore the unsuccessful landing attempts are no longer valid. We join the green dots together by their past light cones to form a new now, and I've relabeled the previous now just now. We can see that this picture is analogous to the situation at cosmic time t. But because of the successful localizations, the wave function has changed somewhat, and this implies that the set of agents has also changed somewhat. Here's a replay. Cosmic time t. Each agent attempts to act. Cosmic time t plus 1. You can go back to review this. There are several advantages to this dynamics. This is a plausible model of competing agents attempting to act in the world. The world line of a long-lived entity is somewhat analogous to a pearl necklace. We don't have a single agent that exists over an extended period of time. Instead, the world line of an entity is recognized as being a sequence of closely related agents. The dynamics gives a natural, wafer-thin, space-like foliation of the universe, and it gives a natural, objective cosmic time. The dynamics gives a reasonable process view of reality, in which the past of the universe is fixed, but the future remains open. Here are some challenges to Pan-idealism. In some cases, I only have provisional answers. We'll look at each in turn. First, is Pan-idealism plausible? Pan-idealism claims that even so-called fundamental particles, such as photons or electrons, are minds, albeit with no ability to think. We know little about their percepts, but we may suppose that they are intrinsically qualitative, and these patches of quality delineate mathematical structures of some unknown kind. These percepts are just sufficient to account for the particle's behavior. We might picture a percept thus. When we put a particle in an experimental situation, it seems to be able to perceive its environment. Technically, the wave function depends upon the entirety of the configuration space. Richard Feynman, by no means a panpsychist, was driven to making a panpsychist metaphor. He wrote, "So light doesn't really travel only in a straight line. It smells the neighboring paths around it." Another issue relating to plausibility is the question, aren't percepts by their very nature highly misleading as a basis for physics? Some physicalists, I'm thinking of Daniel Dennett here, argue that percepts are a hopeless basis for science, on the grounds that they are often misleading. Because of misperception, scientists can be deceived about the physics of the universe, even over many years. The case of N-rays is often cited as an example. Dennett argues that the objective scientific method allows for the quickest possible elimination of such errors. My response is that every scientific measurement or experiment is entirely grounded in mind. The scientific method is entirely grounded in mind. This even includes both producing and reading a scientific journal. Although the universe is real, and it does have a physics, we don't have a godlike, objective, third-person access to it. Going further, while humans can be, and often are, deceived, Pan-idealism accounts for this. In any reasonable universe, very simple minds cannot be mistaken about their environment. This is because they have no cognitive powers, which are essential for any mind to be deluded. In the optimal synthesis that defines any physical quantity, say the position of a pointer on a measuring device, these simple minds numerically overwhelm any human biases that may exist. Pan-idealism, therefore, has an exact objective physics, albeit this is secondary and not fundamental in the ontology. Although the universe could be such that every human person is radically and permanently deluded, taking this possibility seriously is unenlightening. It is akin to adopting solipsism. Next, does Pan-idealism explain agency? In Pan-idealism, agency is the only form of causation. There is no physical causation because physical laws are merely descriptions. Agency is fundamental, and as such, it doesn't need to be explained. Mental causation certainly exists.
The current mantra is the physical world is causally closed. Well, you want to watch and see how consciousness makes a difference to the physical world. I decide to raise my arm and the damn thing goes up.
Does Pan-idealism give a reasonable enumeration of agents? Recall that at cosmic time t, we factorize the wave function of the universe as much as possible, and we conjecture that each of these factors is an agent. In Pan-idealism, the catalogue CT of agents that exist at cosmic time t is the set of these factors. This agrees, at least moderately well, with the vague catalogue VT given by Physicalism. Physicalists can afford to be vague about VT because, according to them, physical entities don't have any intrinsic nature. In contrast, Pan-idealists must be as accurate as possible about CT because, according to us, each member of CT is a mind. I want to give a couple of examples. In a Young-Slits experiment, large molecules, such as Buckminster fullerene or carbon-60, can, as it were, pass through a pair of slits and show interference fringes. Each molecule is sensitive to its entire environment and alters its behavior accordingly. This holism suggests that molecules are minds that can perceive their surroundings. Does each carbon atom within a buckyball retain its own identity as an agent, or is it subsumed within the agency of the molecule as a whole? As it stands, Pan-idealism holds that there is only one agent, the molecule itself. My own view is that Pan-idealism might be improved here, perhaps with a good theory of degrees of entanglement. Here's a more complex example of the same difficulty. While Searle is raising his hand, numerous white blood cells are chasing bacteria in his arm. They carry out their task heedless of his large, relatively slow movement. It seems to me much more plausible than not that these cells and the bacteria are themselves agents, although as yet Pan-idealism doesn't allow for this. The final challenge is, can Pan-idealism explain Qualia? Pan-idealism takes Qualia as basic, so it has no difficulties with Qualia as such. But there are two cases that require further examination. First, can Pan-idealism explain pain? It asserts that pain as experienced by simple entities is no more than a raw feel of repulsion, as when a pair of electrons repel each other. Repulsion is taken literally. Pain in humans and other higher animals involves many cognitive associations. The fear of injury, the pain of extreme hunger, and so on. Sometimes creatures will ignore pains in order to achieve a necessary goal. Animals, including humans, will ignore extreme discomfort in seeking food. They will also ignore extreme pain while fighting predators. A human will endure the pain of a medical treatment in order to be healthy at a later date. Pain is the paradigm example, but all other qualities, for instance redness, also have cognitive associations. The final and most difficult challenge to Pan-idealism is, can it explain human actions that are based on qualia? My initial reply was going to be, no, this is David Chalmers' notorious hard problem of consciousness. Nobody has any satisfactory answer. But then I had an idea. The following ideas didn't appear in my book. In what follows, I'm relying heavily on Richard Feynman's popular but accurate account of quantum electrodynamics. My general idea is to give a speculative account of how fundamental particles might perceive electrons. This is extended to the percepts of complex systems, such as humans. So how might Pan-idealism explain human actions that are based on qualia? Imagine that I'm looking at a vase, and this experience leads me to utter the words, "The blue of this vase is gorgeous." So how does my experience of blue lead me to this physical act? There are many other examples, taking an aspirin when I have a headache and so on. First, we'll consider the naive percepts of simple particles. I want to associate a complex number z with each location x in space. Consider electrons alone. A problem is that they're necessarily entangled with one another. So for simplicity, we'll assume throughout that all electrons are minimally entangled. Suppose there are just two electrons and that their individual wave functions, ignoring the other electron, are psi1 at 1 and psi2 at 2. Here 1 is a possible spatial location for the first electron, and psi1 gives the probability of finding it near there. Likewise for the second electron. Because they are minimally entangled, their combined wave function is given by antisymmetrizing their individual wave functions as shown. This formula can easily be extended to any number of electrons. The complex number z that I'll associate with the location x in space is given by the sum of the two individual wave functions at that location. When there are n electrons, this becomes the sum from 1 to n. This rule is somewhat arbitrary, but I've completed the task I've set myself in the simplest possible way. How are we going to use this function? Here's a color wheel, but colors, at least as humans know them, are rich in associations. For simple particles, we can imagine that this is a wheel of qualia, or raw fields. As with the colors perceived by us, nearby raw fields are closely related. The wheel is stretched out over the entire complex plane. Our formula from the previous slide associates a quality or raw field Qx with each point x in space. It gives evidence of the distribution of the electrons in space. I say gives evidence about because Q holds less information than the combined wave function psi of all the electrons. I'll call C the quality plane and Q the quality function. Where electrons are bunched together, the quality function is more intense. Quantum electrodynamics is an excellent theory of electrons and photons. It is not about mind. My quality function Q is supposed to show the spatial distribution of all electrons as these are perceived by photons. Now let's add in all other particles, protons, neutrons, etc. Recall that Q shows the spatial distribution of all electrons as these are perceived by photons. Where electrons are bunched together or an electron is highly localized, there Q is more intense. In particular, this means that Q shows atomic orbitals. As a result, Q shows the spatial distribution of all particles, atoms, and molecules, and larger objects, as these are perceived by photons. This image of a cat is far from an exact representation of how photons perceive it by way of its electrons. But it does at least give some flimsy impression. According to quantum electrodynamics, photons take every possible route through space. Moreover, as previously seen, there are independent good reasons to defend Pan-idealism. So, the theory as sketched here so far is not too outlandish. We next turn to perception in humans. This is indirect, being mediated through sensory organs. Quantum electrodynamics gives a standard explanation in exquisite detail. In all cases, information is passed by means of photons traveling between electrons. And electrons are constrained in their locality by heavier particles. Press pause if you want to see the details. Here's my theory of human perception. A percept is stored by means of a temporary configuration of electrons within the human brain. Atoms and molecules briefly localize the electrons. The time involved could be extremely short. The percept itself is the quality function of these electrons, as perceived by the photons within or in the immediate vicinity of this system. This percept is an extremely distorted and simplified model of the entity perceived. This image from the Science of Consciousness conference of 2008 symbolizes that our percept may give us a greatly distorted picture of the contents of the world. As for human agency, in Pan-idealism, the brain, with its quality function Q, would be grounded in an agent alpha, having a corresponding percept. More plausibly, there would be a hierarchical system of agents. Agency is fundamental in Pan-idealism, so there's no problem in me saying, based on my percept, The blue of this vase is gorgeous. In conclusion, Tim Maudlin has excellent reasons for optimism. Nothing is comparable to the mind-body problem. It is of supreme importance. It is a metaphysical problem rather than a scientific one. An alternative ontology to physicalism is sorely needed. This new ontology must respect and engage with contemporary physics. The ideas presented here, despite being oversimplified, incomplete, and perhaps incorrect, at least point the way that progress could be made. Professor Maudlin is ideally placed to make progress with this question.